Welcome everyone. So this is a series of binary search trees. We have done insertion and now we will step towards deletion. Okay. So first of all, let revise properties of binary search tree. Duplicates are not allowed. Each node has at most two children. Left subtree of any node will have value lesser than that node, and right subtree of any node will have value greater than that node. Let me tell you again. See, this is a node, its left subtree and its right subtree. Its left subtree will have nodes whose values will be less than this root node, and right subtree will have nodes whose values will be greater than this root node. Okay, so if it is 5 and this is like in this way. Okay, so 4 is less than 5, so it is correct. 7 is greater than 5, it is correct. 6 is greater than 4 and 6 is greater than 5, so it is incorrect. It is not a binary tree. Tree? No, it is not a binary tree because see, 5 is less than 8, so it is correct. 4 is less than 8, it is correct. 9 is greater than 8, it is also correct. So what's the mistake here is that 4 is less than 5. 4 is less than 5, it should come here. Okay, so it is also not a binary search tree. Now let's come to deletion. This is our binary tree. Okay, binary search tree. Now we will delete and see how deletion occurs in binary search trees. Now we have to delete 49. 49 is a leaf node. Leaf node means node which have no child, which has no child. Okay, so 49 has no child, so so we can simply remove it. So if I want to delete a leaf child means no child of that node, so we can delete it directly. So how will delete it? We delete this node and remove it. Okay, so we have deleted 49. So next we have to delete 4. So the case one was we have to delete a node which has no child. Now case 2 is when it has one child. Okay, so how we delete it? Let's see. We have to delete this relation and we have to generate a new relation between its parent and its child. Okay, so this is a new relation and we can simply remove it. If you want to see it again, we have to delete 4. So what we do is, first of all, remove this relation and create a relation between parent and its child. So 4's parent is 6, 4's child is 5. So create a relation between 6 and 5. So in this way, we delete a node which has one child. Okay. So now we have to delete 11. So it's a case 3. In case 1, we have deleted a node who has no child. In case 2, we delete a node which has one child. And the last one is we have to delete a node, case 3, which has which has two children. Okay, so we have to delete 11. 11 has two children. This is one left subtree, this is right subtree. So 11 has two children. So how can we do it? There are two methods. One is in order predecessor and one is in order successor. So we have to remove 11. So how can we do it? First of all, in order predecessor, we see left subtree and choose largest element of left subtree. So largest element is 10. Okay, so what we do is we rewrite 10 here. Okay, we rewrite 10 on 11. See, firstly we had 11 here. Okay, so in order predecessor we see left subtree, we choose largest element, we copy this largest element here. Okay, so what we did is we overwrite 11 by 10 and we can delete this 10 afterwards. Do you get it? Let me show you again. Firstly, we have 11 here. We have to delete this 11 which has two children. So what we do is we see left subtree, we see largest element which is 10. We overwrite this 11 by 10. So this is 10 now. This is 10 now. Okay. Now what we did is we remove this relation. We remove this 10. And we have removed this. Now we see second method to delete, which has two child. This is in order successor. In this, we see right subtree. We see right subtree and find smallest element of right subtree. Smallest element of right subtree is 17. Okay. Now overwrite 11 by 17. We overwrite here by 17. We overwrite 11 by 17, the smallest element of right subtree, and then we delete this 17. So in this way there are two methods to delete a node which has two children. Okay, so we did three cases: a node with no child, a node with one child, and a node with two children. Okay, so this was very easy to delete a node from binary search tree. Now when we delete this, we see that when we delete 11 which has two children, and we did in order successor or in order predecessor method, there is no loss of BST property, that left subtree should be element should be less than 17 and right subtree should have greater than 17. Okay, so this is a property we should मतलब कि वो डिलीट करने के बाद भी वो प्रॉपर्टी रहनी चाहिए BST की. So this was all about deletion in binary search tree. Thank you.